Welcome to 10.3, the surface area of prisms and cylinders. So a little review question from yesterday. We have a polyhedron down here, and we're going to label the face. So remember, a face is basically a rectangle or a plane surface, the edge, and the vertex is a corner. Prism. A polyhedron with exactly two congruent parallel faces called bases. You can see in the example below that's a pentagonal prism. We name it by its bases. The other faces are called lateral faces. Symbols to know: big B is going to mean area of the base, and P is going to equal perimeter of the base. The lateral area is going to be the sum of the areas of the lateral faces. Basically, the area of the rectangles on the sides. And the surface area is going to be the sum of the lateral area and the area of the two bases, which are pentagons, and the example above. So below is a summary of the formulas that I just mentioned. Alright, let's try example 1. Find the lateral area and the surface area of the prism. What is the name of the prism? The name of the prism is a triangular prism. The lateral area is equal to the perimeter of the base times the height. Well, the perimeter of the base, which happens to be this triangle, is 8 plus 15 plus 17. And the height is 18. So the lateral area would equal 8 plus 15 plus 17, which is 40, times 18 would be 720 square centimeters. The area of the base is equal to 1/2 times 8 times 15 because it's a triangle. And the area of the base is 60. So 2b would equal 120 square centimeters. So the surface area is the lateral area plus 2 times the base, which is 720 plus 120, for a grand total of 840 square centimeters. Now pause the video and try example 2 and 3, and then go ahead and continue and see what you do. So example 2, find the lateral and surface area of the prism. The bases are regular polygons. So we have a hexagon. So this is a hexagonal prism. The lateral area, remember, is equal to the perimeter of the base times the lateral edge. So the perimeter of the base times the height, and the perimeter of the base is 4 times 6, and the height is 17. So that would be 408 square centimeters. The surface area is going to equal 408 plus 2 times the area of the base. Well, we have to figure out the area of the hexagon. This is where last chapter comes into play. We know that 1/2 AP. So if this is 4, we know we got 2 and 2, and we have a 60-degree angle here. So this would be 2 square root 3. So the area of the base would be 1/2 AP, which is 1/2 times 2 square root 3, times the perimeter of the base, which we already did above, which would be 24. So this would be 24 square root of 3. So up above, for the surface area, we have 408 plus 2 times the area of the base, which is 24 square root of 3. So we have 408 plus 48 square root of 3. We cannot add those because those are unlike terms or unlike radicals. 408 cannot be added to 48. Example 3. Please find the lateral area and surface area of the prism. So this is another pentagonal prism. If we think about drawing the lateral area The perimeter of the base would be 5 times 3 times 16. So the lateral area is 240 square meters. Now for the pentagon, we know that this is 2. We drop this triangle in. We know that this is 1.5. So we got to find the apothem. A squared plus 1.5 squared equals 2 squared. So we have A squared plus 2.25 equals 4. And then A squared equals 1.75. So A is going to be approximately 1.32. So then the area of the pentagon is going to equal 1/2 times the apothem times the perimeter, which we did above, 15. And we're going to get 9.9 square meters. So then the surface area is the lateral area, 240, plus 2 bases, so 9.9 times 2. And we're going to get 259.8 square meters. Now we're moving on to cylinders. Cylinders are not going to be much different than prisms. They're polyhedron with 2 congruent parallel bases as well, but what you'll notice is that the bases are circles. I've included the net to verify what a cylinder looks like. To find the area of the curved surface of a cylinder, you have to visualize unrolling it. The area of the resulting rectangle is the lateral area of the cylinder, and the lateral area is going to be pi d times h. Think about this. That's the circumference of the circle times the height. Surface area is going to be still the sum of the lateral area and the areas of the 2 circular bases, but instead of, we're just going to have to think about area of a circle as pi r squared. So the lateral area is 2 pi r or pi d times h. Basically that's circumference times h. Very similar to perimeter, but for a circle. The surface area is going to be the same. It's the lateral area plus 2 times pi r squared. So we have to really understand that this 2 comes in from the area of the fact that we're multiplying 2 bases. So example 1, the radius of base of a cylinder is 4 and its height is 6. So we'll draw a cylinder, label the radius 4, the height is 6, and find the surface area in terms of pi. So surface area is equal to lateral area plus 2 times the area of the base. The lateral area from above is their circumference, 2 pi r times the height, which is 6, plus 2 times the area of the bases, which is pi r squared. So we're going to get 48 pi for the lateral area, 32 pi for the area of both bases, for a grand total of 80 pi square inches. Let's try one more example. Again, pause the video and you try example 2 before you continue. So we have a circle. The height is 10. The radius is 10. And again, we're going to find the surface area. So the surface area is equal to the lateral area plus 2 times the area of the base. The lateral area is going to be the perimeter or circumference of the bottom circle. So that's 2 times pi times 10 times the height, which happens to also be 10, plus 2 times the area of the base. The area of the base is pi r squared. So we're going to get 200 pi plus 200 pi for a grand total of 400 pi square centimeters. Good luck on your assignment.